I'm going to tell you the story of climbing Everest to measure the weather, and that sounds like quite a lot of effort to go to. So to begin with, why bother? Well, Everest is situated in high mountain Asia, and as you get a sense from this picture, there's a lot of ice there. 6,000 cubic kilometers of ice, and that might not mean too much. Let's put it this way. If it were to melt, it would generate sufficient water to cover the lower 48 states in a lake 2.5 feet deep. And it is melting. Glaciers worldwide are retreating as temperatures rise. And that can pose challenges to communities downstream. The 1.6 billion people living downstream in high mountain Asia. Too much water in the short term, an increased risk of flooding, and perhaps too little water longer term as there's not much ice left to melt. And that can pose challenges for water supply. So how exactly may the future play out? How quickly may these challenges emerge? We can model it, right, with big data. Well, actually, no, we can't, or at least we can't model it very well, because we don't have big data when it comes to the mountains. We don't have the basic observations of weather required to understand how sensitive the snow and ice up there may be to warming temperatures. There's literally only a handful of weather stations at the required altitudes that we need to understand what's going on. It's a data desert out there. And perhaps one way of communicating that is we know more about the weather on the equator of Mars through the InSight lander than we do about the weather on the upper slopes of Everest, where up to a quarter of the deaths amongst climbers have been attributed to bad weather, or bad weather was a contributing factor. So with all that in mind, one of the goals of the National Geographic and Rolex Perpetual Planet expedition was to try and help fill that data void. So upon arriving in base camp in April of this year, the team immediately set about installing new weather sensors, new weather stations in that vicinity. It's around 5,300 meters. Weather stations do things like measure the amount of energy that's available to melt the snow and ice. But we wanted to do more than that. We wanted to go to elevations that hadn't been monitored before. So we joined the pilgrimage of other climbers in trying to ascend the mountain, trying to climb Everest. So going up the fixed lines, climbing the ladders, moving at night through the icefall, which is what you see behind me here. Moving at night and trying to move quickly. Trying to move quickly because we're trying to avoid things like this, the avalanches that plague the lower mountain, the icefall area and near base camp. So all climbers are in it together. We're all trying to move at night, move quickly, trying to get through this space as quickly as possible. But when anyone tries to do anything, sometimes things don't work out as it planned. So spend some time queuing, and that's us queuing here in a now infamous spot in the icefall below two large ladders. So we're moving through the icefall here, and we are following the main climbing route in Nepal, so the southern side of the mountain. Just seen us moving through the icefall, and we're going to head up into the western Coombe, this big snowy bowl, move up through that, go up the Lhotse face at the back of the bowl, back of the Coombe, and then up and as close to the summit as possible, just like all the other climbers. But unlike the other climbers, we were dropping off weather stations along the way, like this one at Camp 2, which was temporarily the highest in the world. And the data from this station are already showing us some pretty interesting things. Like, for example, it melts up there quite frequently, even though air temperatures only very rarely go above the melting point. And that's really been quite a surprise to us. But we weren't done there. We wanted to go higher. So we carried on through the western Coombe and then up the Lhotse face at the back of the Coombe, towards the South Col, where we installed the then highest weather station in the world. And the weather station there has already shown some interesting things. Like, for example, hurricane-force winds in the climbing season are not uncommon, and neither is melt, even though the air temperatures never go above freezing here. And the melt there is driven by intense solar radiation on the upper slopes of Everest. And the fact that the ice is already melting up there means it may be more sensitive, or the glaciers in the region may be more sensitive to warming than we thought. So how high does the melt go on Everest? And what's the weather like really high up, close to the summit? Well, we wanted to find out. So we set off from the South Col, which is where this picture is taken from. And you're looking up at the summit here. And our goal was to get as close as we could and put a weather station as high as we could to find out what's going on up there. So we left on the night of the 22nd, climbing through the darkness, a bit more queuing, and arrived at the balcony where we decided to set up this weather station. In the shadow of the south summit that you can see at the top of the picture, and Mount Lhotse is behind us, that you'll see in a moment. So working through the dawn hours with an incredible Sherpa team that made this possible, we topped out the weather station at 8,430 meters, first in the death zone in the early hours of the morning. And what are the data showing from these weather stations really high up on Everest? Well, Interestingly enough, the environment actually is not so dissimilar to Mars. In fact, sometimes it's windier and colder than the surface of Mars. And not unlike Mars, the data hint at the possibility of liquid water in the most unlikely of places. Thank you.